Hello everyone. Today I want to talk about Packet Tracer 922 configure OSPF advanced features. As you know, OSPF is a form of routing protocol that help us to choose the best path to the destination. And in OSPF, we have some features that help us about our purpose. In this activity, we should modify OSPF default setting and also verify connectivity. In other words, for example, PC3 can get access to web server using this path, I mean from R3 to R2, and after that here, or maybe choose R3, R1, R2, this path to access to web server. And sometimes we can manipulate and modify some features and help, for example, PC3 to get access to web server via other passes. This is maybe about security and about some access and whatever. And in this part, modify OSPF default setting, test connectivity between all end devices. For example, we can test connectivity from PC1 to server. If you click on fast forward, you can see get information uh, immediately. And also, for example, PC2 also can ping server and also can ping, for example, uh, can ping PC3 or not. And you can also test, all the devices can test and can ping each other, and it's successful. Before modifying the OSPF setting, we should verify that all PCs can ping web server and also each other. Adjust hello and the timers between R2 and R1. And also, we have any concept and we have any feature in OSPF. OSPF uses hello packet uh, to make adjacency with other routers in the area, and also it's like it works like a control if a neighbor is still alive or not. This is hello interval, and it's been how often we send the hello packet. And also we have a dead interval. It defines how long we should wait for hello packet before we declare the neighbor dead. If this time uh, is over, it means this router has been dead, and uh, for example, router 1 cannot get any information and update from other router. Yes. And this is a hello packet and dead also packet. And every 10 seconds can get hello packet, and every 40 seconds can get dead also interval. But to speed up this process, we can play with the timers, and we can manipulate and modify these timers, and also vice versa. Maybe we can set other hello interval, like instead of 10 we can get access, we can set 15. In router 1 we should go here and in configure terminal and interface, which interface that connected to router, for example 2. This is serial 000, this interface serial 000, and you can set IP OSPF hello packet to hello interval to 15. And also we have det. It should be yes 60. Yes. After a short period of time, the OSPF connection with router 2 will fail. We can click on fast forward and can see here OSPF adjacency. It's process from full to down. Yes. Why? Both sides of connection need to have the same timers for the adjacency to be maintained. Adjust the timer on order 2. It means if you, for example, modify this interface, hello packet and det packet, and also it should be same for R2 in the other side that connected and directly connected to R1. You should go here and enable and configure terminal and interface. Which interface that we have here? We have interface serial 000. Yes. And right here again, IP OSPF, hello packet 15, and also det 60. And if you click on fast forward, you can see from loading to full again, and adjacency has been made again. Adjust the bandwidth setting on R1, and also we can modify bandwidth. Another thing that we have here, um, bandwidth, because OSPF uses metric and uses cost to get access to some destination. For example, between router 2 to PC3, for example, we have 2 paths here, and we can manipulate and modify cost to get access to PC3 using R3 or using R1 R3 to PC3. And in an OSPF uses a simple formula to calculate the OSPF cost for an interface, and cost is 100 divides on interface bandwidth. And other thing is important here, lower bandwidth has a higher cost, and lower cost value between source and destination will be selected for routing table. And it means the lowest cost will be chosen and will be selected for any devices here. And sometimes, for example, here you can adjust and you can modify also bandwidth. Trace the path between PC1 and the web server located here. This is PC1 here. You can trace routes, and this is IP address of server, and you can see to access to web server, go to 172.16.3.2. It means here R1, and after that R2, and after that this is the IP address of link between R2 internet and also here. But we want to choose other paths. We want to choose PC1, R1, R3, R2 here. And in this situation, we can, on serial 1, we can modify serial 00 bandwidth and cost. And you can say here, bandwidth should be 64, and it's very, very bad bandwidth. And in this situation, cost will be um, large, and um, in this situation, um, PC1 can get access to a web server via this link, and can maybe remove it it's better to say R1 remove it from addressing table about best pass. And now we can click on pass forwards, and again trace route. You can see difference between before and after this comment that we have done here, bandwidth 64, and cost for this link will be very, very much and very, very big. And in this situation, PC1 go to this link here, and after that 192.168.10.4, and after that 106, this one 10.6, yes, and this one, and also this one here. Yes, this pass has been um, choose and selected in this scenario. And you can also see here on R1 set the bandwidth on 64 kilobyte. This does not change the actual port speed. This is very important. This this does not change the actual port speed, only the metric or cost that the OSPF process on R1 will use to calculate the password. Trace the path between PC1 and the web server. Notice that the path from PC1 to web server is directed through R3 here. Also we have seen here. Yes, this is IP address of R2 R3. Yes, and OSPF prefers the lower cost path, and also is very important how OSPF choose any path. And verify connectivity. All the pieces can also ping each other. Yes, for example, you can check again. You can ping, for example, from PC1 ping web server, and also other devices can ping each other. And there is not any problem here. Yes, they can ping each other. Yes, it was about two feature. Um, manipulate metric and cost, and also manipulate hello and dead timer between R1 and R2. Thank you for watching, and have a nice day.